Alright folks, we discussed about receiver sensitivity of general receiver chain and a transmit chain. I suppose now that is sufficient for you in this course to decide how to choose a radio for your application, particularly when you are looking at data sheets of SOC manufacturers. One such SOC manufacturer which again I would like to point you to is NRF 52840. This is Nordic radio SOC. Now let us just look at the radio part of the SOC. What does it say? It supports Bluetooth 5, that clearly indicates there must have been a Bluetooth 4, there must have been an earlier version of Bluetooth as well, right. And it also says that look, I am not stopping at just supporting Bluetooth 5, I can also support IEEE 802.15.4 2006 version. That means there must have been a version which is 15.4 2000 something else greater than that. There is indeed a version which is 2011, there is a 2012 version and so on. So which clearly indicates if you come to the area of radios, you have to be very clear about which version you are looking at, okay. So you can see that that is true for both types of technologies which it supports. Now what is the beauty of this? Broadly this is Bluetooth and this is Zigbee. IEEE 802.15.4-2006 is the MAC and PHY, medium access control and physical layer, right, MAC and PHY of the OSI stack, which is exploited by a consortium called Zigbee. Zigbee uses this particular IEEE 802.15.4-2006 MAC and PHY layer, that is what it means. You can also develop native applications on top of this MAC and PHY, but Zigbee is one such standard which is a consortium of people of a consortium of companies which wanted to use this, and they have defined certain things as part of their upper layer stack. Now beauty is the same SOC can be configured for either Bluetooth or for Zigbee in a way. Why? Because remember I mentioned to you about the generic RX chain and the generic receive chain and the receiver sensitivity which I was talking to you about. Now you have to know a little more about this particular radio. So look at what he says, minus 95 dBm is the sensitivity in 1 Mbps. It is greater than that, it goes down to 103 dBm sensitivity if you reduce the data rate, right. So 125 kbps gives you 103 dBm. What is the transmit power of this radio? Minus 20 to plus 8 dBm is the transmit power in steps of 4 dB. Now clearly this Bluetooth 5 supports what all data rate it supports, it is mentioned inside this SOC, gives you 2 Mbps, 1 Mbps, 500 and 125 kbps, and clearly sensitivity is changing based on the data rate. Now you can evaluate, you have now seen Nordic, go and look at some TI SOC or look at NXP SOC or look up STM SOC and find out how these compare and what your application is, what kind of range you want to support. Everything will depend on what is available from the radio, right. And in this complete course I never really pushed you very hard towards security, but folks it is actually integrated, okay, and you need to understand the security aspect all by yourself independent of what I teach in this course, because everything that I teach here assumes that there is security, and indeed there is. You can see it supports 128 AES, elliptic key, ECB security, CCM and so on, right. So all of that is possible well within the security module or security specification of the system. So that is possible also. So now you have the energy aspects which are indicated here, we will not get into that because we did that already in the other modules there, okay. So connecting back, these are the key important parameters that you may want to look up. Before we delve into anything related to Bluetooth, you must understand a few things about the Bluetooth protocol itself, okay. So let us go and spend a little time about Bluetooth low energy as a technology. Now think of two nodes, okay, this is node 1 and this is node 2, okay. And now how these two nodes are communicating indeed depends on several terminologies which are part of this Bluetooth low energy. You should know those terminologies very well. Of prime importance to you will be these two terminologies, what is a peripheral and what is a central, who is a master and who is a slave. If you know these things well, you can read the documents which are associated with Bluetooth in a much more detailed way, okay. So I will get into some detailing here, and for that I will take the support and assistance of a few files which you can also download very easily, okay. So for that let me start with this document, which is actually a collection of some terms and names which we put together in this document. If required we can share it with you, but I am sure you will find much superior documents out there if you just Google for it. In fact it is quite rich, the internet is quite rich in several documents, so you can download. But let me get into some detailing here. Now I mentioned to you Bluetooth 5, which means Bluetooth 4 must have been there, and that is what is shown here, and that is as old as 2010, which is quite some more than a decade back, right. And then there are some names associated, there is something called Bluetooth Classic and so on. So do not worry so much about these Bluetooth Classic and Bluetooth low energy and all that. These are all terms which have evolved, but as engineers, as people who are using, you should know some nice things. So if you look at Classic, it is used for some streaming applications, audio streaming and file transfers, and Bluetooth low energy is what is of great interest to us, because that is where sensor data communication comes in a big way, control comes in a big way, and low bandwidth applications come in a big way, right. So although there are some differences of that nature, what comes to my mind is, if you look at BLE, it offers you 40 RF channels as against in the Classic which was 79 RF channels. Now folks, it is not difficult for you to break your head on how this is becoming so many channels here, at what compromise. Remember that the whole range is the ISM band which we defined in the 2.4 gigahertz. If you are getting 40 RF channels in BLE and 79 channels in Bluetooth Classic, clearly the bandwidth of each channel must have been different, roughly it must be twice, right. Okay. So in fact that is the truth of the matter. You have a larger bandwidth in the BLE case and you have a shorter bandwidth in the Classic case. That is all the difference folks. This you should not think more than that in this whole thing. Now Bluetooth 5 came up in 2016, and that is what it says here, alright. Now then you can go into say that why did Bluetooth Classic go away and why did BLE come in a big way and all that. We mentioned that yeah, it is meant for sensor applications. Indeed it is a low power consumption device technology, and it is meant for sending small amounts of data at low transfer speeds and all that, and the cost of these modules are also going to go down. So it is interesting because you can integrate your technology well and make it work with the most ubiquitous device today existent, and I am sure more than 7 billion population of the world. I am sure a large segment of them hold on to mobile phones, and out of that a significant number of them, a large fairly significant amount of them actually have smartphones. So if you build an IoT device with BLE, it is highly probable that you will be able to talk to your smartphone, and that is perhaps the reason why you should use BLE. Now it is not that BLE is all that great, it does have certain limitations, and those limitations are mentioned here, like data throughput is something that you may want to look up, and range, okay, range is another compromise that you will have, and then essentially Bluetooth low energy will definitely require you to connect to via a internet gateway in order to get it out on get the data that you acquired through Bluetooth onto the internet. So, so you need a BLE device that has an internet IP connection, and then in turn it will relay the data to other IP network connections. So, that is something that you will have to take note of. So, this is a general picture. Again, I would not like to go into the detail of this, do spend time reading it yourself. There is a PHY layer as I mentioned, and this is obviously working in the ISM band. Remember, if you are putting up channels, you have to ensure that adjacent channel interferences are reduced, and therefore you need super filters. Go back to the picture I drew about the filters at the output and at the output of the transmitter and the input of the receivers, right. All of that will ensure that you are sticking to that particular channel in the most effective manner. Then you have link layer, you have higher levels of abstraction which you will see as you go along and read this standard. Then what is important is I think you should know this very well, because this will actually connect to the picture I drew here. Okay. Advertisements and connection establishment and security are important aspects, and why? Because it connects to this picture very well. Okay. So, let us spend a little time understanding these advertisements in a little detail, connection establishment and so on. Now, BLE devices, if you take this device, okay, this device has many roles, and what are the roles? Look, here are the roles which are defined here. You can see this many roles are defined. Now, which is a clear indicator that you can have a broadcaster type of role, observer type of role, central type of role and peripheral type of role. Now, as I mentioned to you in this picture, peripheral was shown. You can see this, we were talking about peripheral. Yeah, so you can see I wrote peripheral and central, master and slave. So, let us go back and look up what we mean by peripheral. See folks, of great importance is this role of this device as a peripheral. What this simply means is the device that advertises and accepts connections from a central device. Okay. Now, what is a central device? Central device is a device that discovers and listens to other devices that are advertising. A central device has the capability of connecting to an advertising device. So, let us put that picture. This guy says I am available, I am available, I am available, I am available, I am available. This guy is listening. So, he says he gets it, right. If you do it this way, it is not going to reach. So, I am going to change this and show I am available, I am available, I am available, and like that it goes, and this node listens to that, and once it listens, it says great, I know that so and so node exists. Like that you can have other nodes, right. There can be another node 3, let us say, he will also advertise. So, the way to start a connection is to first advertise. So, you need to if two devices have to locate and do a communication between themselves, they have to do what? They have to discover. If I do not know who you are and you do not know where I am, how do we ever communicate? So, therefore, discover is an important step. This essentially is leading us to the fact that nodes try to advertise themselves. Now, when you talk about advertising, how often should they advertise is the question. That will come to your mind immediately. Oh, how often? If I look at the whole course and the structure of the course, if I do very often, I am going to burn up a lot of energy. If I do not advertise very often, I am not going to get a connection quickly. So, you need to compromise between the two. Therefore, the standard says, hey guys, you can advertise at an interval which I will tell you. The standard says the advertising interval can be anywhere from 20 milliseconds to 10.24 seconds. Okay. And what is the gap? What is the step size? 0.625 milliseconds. That is it, folks. Your next one, if it is 20, you cannot set it to, you can even set it to 20.625. Then you add another 0.625 and go to the next one, and so on and so forth. You can go up to 10.24 seconds. That is the beauty. This is a handle for what? This is a handle for what? This is a handle for battery, lifetime, and so on. Please note that. Okay. So, this is what you must know, that BLE peripheral devices you can set the advertising interval. So, we already know a little bit about that. Now, central is the device which listens and discovers and listens to other devices that are advertising, and it says okay, great, we can connect to each other and start communicating. So, that is essentially what was written here. Advertising state means device sends out a packet, and there are 40 RF channels, and each are separated by 2 megahertz, some detailing is there, and then there are 3 primary advertising channels and the remaining are 37 channels. Again folks, go back, do not worry so much about the advertising channels and all that. What do you want to do? You are saying I am available some interval later, advertising interval later, I am available and I am available, or I am so and so, either available or so and so. Now you know that there is a possibility to play with the advertising interval. You can also the standard also says you should advertise on known channels, otherwise how will this guy ever receive it. So, what actually happens is this guy will sit on any one of the 3 channels. It is called 37 channel, 38 channel and 39 channel. Okay. Now, when this guy is transmitting on 37, there is a very good possibility the receiver is on 38. It is possible because it is all unsynchronized at the moment. Okay. And then when the advertiser moved from 37 to 38, it is possible that this node went to 39. Okay. Therefore, connection between the advertiser and the central may take a few a little bit of time, before which they will be able to catch up and they will be able to communicate among themselves. So, do not expect that moment this guy sent out at 37 that the central actually got it, because it may be on a different channel. Therefore, you have to ensure that wait for a significant amount of time, not significant, I would say sufficient amount of time, such that at some point in time the node, the receiver will be able to get the data, right. So, this is important, and there are timers which you have to adjust such that even the central device, for instance one simple thing you can do, right. What you can do is, supposing you are shifting every 20 milliseconds from one channel to the other. So, if you start now, next 20 millisecond later you are on 37, from 37 you move to here, you did on 37, right. At this point in time the central was on 38. So, it was on 38. Okay. Now, from 37 after 20 milliseconds you move to 38, and after 20 milliseconds you move to 37, 38 and 39, and after 20 milliseconds you went back to 37. Okay. Now, that means 20, 20 and then another 20, right. If you are able to adjust the central to be on that channel for 60 milliseconds, you will definitely catch it. That is all I am saying. Put the central to 60 milliseconds. So, you adjust in a manner. So, these are things that will let you adjust in a manner that you will be able to ensure that the the advertiser and the central will be able to communicate, will be able to transmit and receive successfully. So folks, these are things that you have to keep in mind, and you know, all these things you have to experiment and take the support of the developer, okay, and you will be able to adjust these things. So do not think that all this will happen by magic. You have to put an effort and go back to the advertiser, I mean to the vendor of the device, and then accordingly manage these things. So that is what this picture is actually saying, that advertising data is happening on 37, 38 and 39. There is a nice thing about this picture. What this is saying is 37 and 38 are number wise they are one next to the other, but frequency wise they are not. Look, where is 37? 2400. Where is 38? It is between 2420 and 2430. Similarly, where is 39? It is at 2480. It is at 2480. So number wise it may be one next to the other, but not necessarily adjacent frequencies. Look carefully, 0 to 9 is shown here, in fact 0 to 10 are shown, and then you have 38 here, that is what you should make a note. So this is channel 38 reserved for this frequency band is channel 38, okay. So that is very important. And why is it done that way? Because if you do 37, 38 and 39 one next to the other, if there is a problem of interference in a given frequency band, if you put 37, 38, 38 and 39 one next to the other and the interference is in that band, there is no chance that you will actually get the packet, because all data one next to the other would be gone. Therefore, you keep them far apart, send one, I am available here, and after whatever advertising interval time send one here which is far apart in frequency band, and if there is indeed a fading, if there is indeed a problem on this channel, up to this point you may not receive anything, but then luckily you may be able to get here. Similarly, between 38 and 39, if there is a problem of interference across this full band, you do not need to worry, because at this is the frequency at which 39 is situated, and therefore this becomes a big advantage for you to ensure that reliability of advertising packets are captured, improved because of this spacing of these systems. So essentially it is that. Yeah. Then there is this issue of scanning. Centrals tune into the 3 primary advertising channels one at a time. So the central, so in order for a central to discover a peripheral, the central has to be tuned into the same channel. I mentioned this already. The question of to increase the possibility of this happening, and in order to make it quickly happen, advertising and scanning parameters can be adjusted. I mentioned this already to you with an example, okay. So connections, now that 2 or more devices have discovered themselves, you can establish a connection between the two. What is the advantage is the question. See, you can do data exchange in one direction even without establishing a connection, okay. What does it mean? It simply means this guy who is advertising can put some payload into it, which is temperature payload, and give it to the central node. He is actually doing a data communication. It is not only saying I am available. This is the advertiser and this is the central. So you do not like the word advertiser, so let us call it the word peripheral, because that is what we defined, okay. I will go back to the same notion of, yeah, we said peripheral and central, right. So let us do peripheral and central. Now this guy, when he is advertising on any one of the channels, he can actually also send the data. If he is not going to, if he does not want to get anything back from the central, he can simply send that and say, okay, take it, I am giving you my data, maybe I am giving you temperature data, So, you can also do communication between peripheral and central, quick communication without establishing any connection by simply sending out the data as a part of the payload. This becomes highly energy efficient. I will tell you why. Because central, let us say, is connected to a large power source, and he sits on the channel for a longer period of time, as we discussed last time. Peripheral can wake up from deep sleep, do a sensing on the ADC and use this BLE radio and push this data on 37, and he can also push the data on 38, he can also push the data on 39. For sure the central will be available on any one of them. So, he can send out 3 advertising packets without connecting to the central. This is possible only when you are in the broadcasting mode or in the advertising mode, okay. But that is not always the case. You also want the central to give you back some data, which means you must do a half duplex connection. Basically most of these radios that we discuss are all half duplex connection radios, and therefore you want bidirectional half duplex between the central and the peripheral. Now here is the another point that you should know, and that point that you should know is with respect to the important point with respect to that is, after I have discovered, the central may say, why not we establish a connection. So, they exchange a set of packets, and then this is peripheral and this is central, they exchange a set of packets and then a connection is established. This is a connection, okay. Once a connection is established, this is called a connection event. This is called a connection event. Once a connection is made, you do not have to get into the issue of again trying to discover the central and all that, okay. Once discovered is done, you do not have to worry about it. You can go and sleep and central can do whatever it wants. You can wake up next time and you can simply send it to the central, because you have already established a connection earlier. But you must tell the central how often you are going to come back and transmit your data to the central. Now that is also configurable, that is the beauty, and that term is called connection interval. Connection interval. So how is it defined? It is the time between two data transfer events, okay. These are what events? BLE connection events, BLE connection events, okay. And this is configurable. What is that configuration? Great, you asked a good question. You can configure it from 7.5 milliseconds to 4 seconds. You can configure it from 7.5 milliseconds to 4 seconds, okay. And what is the increment of 1.25 milliseconds increment? What does it mean? 7.5 plus 1.25, 5, 7, 8, 8.25 milliseconds can be the next if you are putting it to the minimum. Maximum can be up to 4 seconds. Folks, again this is important. Why is this important? Because if you do not tune these parameters properly, you will not get 10 years lifetime. 10 plus years lifetime. You can do lot of tricks here folks, and Bluetooth low energy lets you do all those tricks. Okay. So, I will first write advertising interval, and the second point is connection interval. Okay. These are both very important parameters for 10 plus years lifetime. Okay, folks, there are some tricks here. See, Bluetooth says, alright, now let me draw the timeline, and this is one CI, second CI is here, third CI is here, fourth CI is here, and so on. Okay. In this CI what happens? We said that this is one CI, second CI, and so on. This is the interval, these are the CIs. Actually this is what I should draw, I think this is incorrect, let me draw again. This is CI 1, CI 2, CI 3. This period should be long enough such that you will be able to send something from the peripheral and get back an acknowledgement from the central and decently exchange data, right, in both directions. It should be managed, it should be set in such a manner that successful data communication on a half duplex link is possible. Now, there is some nice feature in BLE where the peripheral can actually skip a few CIs. You can skip. Okay. Skipping CI means what? You are not incurring any overhead of energy. You do not have to wake up, you do not have to set up a connection. Okay. Forget about advertisement, advertisement is already finished, right. You finished all that, you discovered, discovery was over. On an already established connection, you do not have to re-establish, or you do not have to go back and say I have to connect back to you because I declared that I am going to connect to you every CI times. You do not have to do that. So, you can skip a few of them, and that is what we meant by the definition of this whole thing related to master and slave. So, master and slave notion comes after they have discovered and they have connected. This is a term which you can use only after the peripheral and the central are connected. Now, central becomes the master, peripheral becomes the slave. Why is it like that? Because master can connect to multiple slaves. Of course, it will have to manage nicely between the different slaves which are there. It has to remember which what is the connection interval of this slave and tune itself to that particular frequency and wait there, and then it has to go back and then get data from other slaves which are connected and all that. So, the management routines on the central are quite complicated. Okay. So, you have to note all of that. So, therefore, this is another important tuning parameter which I wanted to tell you. So, now let us go back. So, here you have two Bluetooth devices connected to each other, and central device needs to be in scanning mode so that it will be able to listen to advertisement from coming from the peripherals. Okay. So, it is in the scanning mode. Can you get data in a scanning mode? The answer is big yes. The advertiser can give away some data and so on. Connection events, I discussed this already, right. Connection event, what should it contain? At least one packet sent by the master. Slave always sends a packet back if it received a packet from the master. Okay. If the master does not receive a packet back from the slave, the master will close the connection event. It resumes sending packets at the next connection event, because that was what was agreed upon between the master and the slave. The starting points of consecutive connection events are spaced by a period of time called the connection interval. The starting points of consecutive connection events are spaced by a period of time called the connection interval. Okay. the interval at which two connected BLE devices wake up. So here is the definition, right. The interval at which two connected BLE devices wake up the radio and exchange data at each connection event, that is what I draw in the picture. Now this is what I was trying to tell you about slave latency. Look at this parameter. It says the peripheral can skip a number of consecutive connection events because it did not want to wake up. Maybe it did not have sufficient battery, maybe it did not have data to send. So many reasons why it did not want to wake up. So what it will do is it will not listen to the central at these connection events, it will just say forget it, I do not have energy, I do not have data, I do not want to listen, whatever be the reason, and then say I will allow 3 skips. So you will do a slave latency of 3 skips. Connection events which have a value of 0 means slave has to send data to the master at every connection event. Otherwise if you say slave latency of 3 means you can skip the in between connection events and then send out the data packet. So here is where the master will have to take stock of everything. Supervision timeout, the maximum time between two received data packets before the connection is considered as lost. So there are some terms associated with it. Alright, so client, server, master, slave and so on, these are all important terms. Please read the document so you will get to know much better. Okay. Now whenever you talk about BLE, you will be talking about services and characteristics. You have to see these are the most used terms as this document says, and so you must understand them, and that is crucial especially for BLE devices that establish a connection with each other. Alright folks, question of different roles of BLE nodes we have understood now, and we did talk about the connection interval as well, right. We also mentioned about the connection interval and the advertisement interval and so on. What is its impact on energy consumption is the question, right. Also one important point I wanted to say is there is this without connecting between having established a full fledged connection between the peripheral and the central, there is still a possibility to transfer data in either direction. Basically it uses scan request and scan response, okay. These are things which are commands which are easily possible where data can be exchanged between them. So setting that aside, the impact of connection interval and on the battery life of the system is a very important calculation to do, okay. And therefore we must see how to connect these bullets, because we said that one can easily overwhelm and configure it in a manner that you completely destroy the ability of the node to provide you this 10 plus years lifetime, okay. So that is a very important aspect, and let us take an example to demonstrate how the impact actually comes up. So for that what I did was I took a application note which is beautifully written by these two people. This is from TI, okay, measuring Bluetooth low energy power consumption. I think you should read this article very well. I will give you an overview of this article, but I am not going to spend every line trying to explain this. Therefore read this article very you can just download it, okay. It is available freely, you can just download it. This is the title of the article, just download and read it. So the goal is the same, you want 10 plus years of operating and you are talking about a coin cell battery, typically something like CR2032, which gives you some 240 or 250 milliampere hour. It is a small coin cell milliampere hour battery, right. Now authors go into giving you a beautiful feel for the problem. This is what we already know very well. What is happening here? You have connection event, then you have sleeping, then you have another connection event, sleeping, connection event and sleeping. Now our problem is how is this connection event, what is its energy consumption in this connection event, because you can see significant amount of time it is sleeping, but then this is typical of any sensor node, right. You will an IoT node, whenever it wants to transmit it will establish a connection event with the central, the peripheral will establish with the central and then it will move on. Only first time as I mentioned it has to do all that broadcasting and so on, and then establish a connection between the two of them, and repeated connections can be simply use this connection event essentially. So this is the same picture that you know very well. Now every time the node wakes up and it wants to transmit something, this is what will happen in the node. Kindly recall, this sleeping is the same as this sleeping. Now we are interested in expanding this part. How does this part look like? This will simply look like wake up, RX, reception mode of the radio, this is the transmission mode of the radio, some processing, right, and then doing something additional and then going back to sleep. Broadly this is what it is. There are no further details here, okay, and we are talking about a key fob, okay, and Bluetooth enabled key fob, and you want to estimate the lifetime of that key fob. So this whole story is about that. AN092 application note is about that. So figure 2 is very straightforward. This is something that we know very well, and x axis is time, y axis is the current consumption, okay, this is how it looks, the waveform. Now then the article goes on to talk about how you get these spikes, okay. For example, this spike, how did this spike come is a question. So they write a beautiful expansion here. The digital voltage regulator is turned off along with some oscillators. Then the only way the device will wake up is if an IO interrupt or sleep timer occurs, interrupt occurs and all that. Then he says that the real energy consumption is all about trying to get to this average current, okay. Average current into time will actually give you milliampere or whatever into time, and if the voltage is known, you actually know the energy, okay. Note that a single average current value cannot be given. You cannot actually say what is the average current, it is not possible. How can you find out the average current? You have to take some sort of time over which this amount of current was consumed for this time, this amount of current for this much time, and so on, and then you add up everything, then you may get one average current value, right. So that is what he has written here, and this is something that we know very well, okay. Now he also says that for the complete system on a chip like CC2541 and all that, you have to understand that the MCU is typically not only running the radio stack, but it is doing so many other things. It is operating the ADC for sensing, and the MCU may be in some other state, it has to wake up, acquire data from the sensor data via the ADC, so on. So it is important to be aware that other sources of current consumption will also affect the battery. So it's whatever you measure is not going to be straightforward. Now this test setup is pretty straightforward. If you read it carefully, it only simply boils down to just this, that is, he wants you to put a 10 ohm resistor in series, it is like a shunt, and this is your BLE peripheral of interest. You connect it to a oscilloscope probe, a voltage, you put it, you get it directly into voltage, you can measure the voltage, which is already you know the current profile because you know the current passing through a fixed 10 ohm resistor. Very accurate 10 ohm resistor is already good enough. So essentially he is talking to you about that that setup here, okay. Now embedded software modifications have to be done because you are connecting it to a power supply. You may want to do a few things. Device immediately starts advertising upon power up and will accept any connection request from a master device is something that you may have to change in your software stack, and you do some other couple of modifications that can help you reduce the unnecessary power consumption, okay. Now remove periodic events, this is another important step, and you configure anything that will periodically occur, you just remove, because you are only interested in the power consumption of the particular radio, because that is what your whole interest is. Because if you recall, the title of this article is you are interested in measuring Bluetooth low energy power consumption, you are not interested in any other periodic events which will keep bothering you, alright. So that is your focus, alright. So having said that part, you may also want to check the peripherals of the SOC. If there are other peripherals like GPIOs which are on, you keep them off so that no leakage of current will occur, that is another important thing, okay. Now the advertisement and scan response data, which is a two-way communication between the peripheral and the central, without connecting, very important, without establishing a connection, can also be done, and that in order to show you those message exchanges you need a tool, and that they are asking if you are interested you can go and look up this BT tool log window, and now you are ready to form a connection between the devices. So essentially all the messages which are passed before making connection establishment you can actually see with this BT tool. Okay. Now here is the problem setting. He says, these authors say, let us take Ci of 1 second with 0 slave latency. Fantastic. So you actually know what this means, 0 slave you know, and you also know that the Ci is set to 1 second. So you do all kinds of settings here, and then you use the BT tool, and then you configure it, and then you will end up with this picture. This is single triggered capture of a waveform. Okay. X axis is time, y axis is the current consumption, because we already have the current shunt resistor in series, you can actually measure it. Okay. Now he writes here, so because the voltage is measured across the 10 ohm resistor, the current level can easily be calculated by dividing the voltage by 10, correct. One of the first things that you may notice when looking at the capture is a large spike in current at the moment when MCU wakes up from sleep. This spike is caused by the digital voltage regulator inside the CC2541 repowering up. This is the thing, whenever you talk about SOCs you have regulators inside, the regulator kicks up. Whenever there is a regulator kick, I showed you this already, no one really knew at that time why it came, but you actually know now that this kick is coming because of the voltage regulator waking up. Okay. So this is an important thing. So you have MCU wake up, pre-processing, which essentially means the BLE protocol stack prepares the radio for sending and receiving data. Then you have pre-reception, radio turns on the preparation of RX to TX. So it is basically a state machine transition from RX to TX. RX essentially means the radio receiver is in reception, listens to packet from the master. RX to TX transition is essentially the receiver stops and the radio prepares to transmit a packet to the master, and so on. TX is radio transmits a packet to the master. This whole view, this whole article is written with the view of a key fob, that is important. Okay, it is with respect to the peripheral, because the peripheral is the one that has that CR2032 battery. So you are interested in estimating the lifetime of that peripheral. Think about your car key and the battery inside that. This calculation actually matches that. It is your car key fob, that is what you are interested in. So all these things are with respect to the MCU on the key fob and so on. Alright, a similar waveform can be captured during every connection event. However, the amount of time for each state will vary depending on the circumstances, all that he writes. In addition, if more than one packet is transmitted or received, there will be additional RX, TX and transition states and all that. Right now you can restrict it to just one reception and one transmission perhaps, so that you can understand the complete energy consumption much more clearly, right. Now this is figure 7, what you saw here is indeed figure 7, and now he writes a sentence about figure 7. Now figure 7 appears like it can be used to start performing measurements. It does not tell us the entire story, that is the problem. Now in figure 8 you see the entire story. Okay. Figure 8 below, the voltage waveform is captured again using a rising edge trigger. Set the trigger each time that the CC2541 wakes for a connection event. This time the oscilloscope's persistent feature is used, in which many captures are overlaid on top of one another. Look at this line, it is so thick, one after the other after the other after the other, you go on tracing one after the other. So one thin line is one measurement, second line on top of it is like second measurement. So you can see how many measurements must have done. But what you find is this very interesting thing folks, it is now a bit of a spread here, right, because of this additional measurement. So you look at 7, and then look at 8, you see 7 is like this, okay, single trigger capture of waveform, it is just one line, one capture trace. Think of what would happen if you did it again like this and like this, again you do, it goes on top of this, that is what you do, you get here, right. This is what you are trying to say. Now you see from figure 8 you can deduce some interesting things. Okay. One of the things is about the current consumption during connection events. First of all, the processing time for each connection event is not exactly the same, that is the one problem that he notices. This means single scope capture is not sufficient because there is a range over which the current is varying. In fact the time is varying and because time varies the current consumption will vary and therefore energy will vary. This is the big takeaway. The next point to notice is that even though there is variance in processing time from event to event, the total processing time is not completely random but rather falls into some sort of slots. Okay. Now this is what he is talking about, processing time slots. Events that fall into shortest slot take less time to process and therefore less power is consumed. Okay. And that he says is 2.6 milliseconds. This is the shortest slot take less time. So this is the shortest slot. The longer slot is the 2.7 milliseconds. So essentially he shows it here, from here to here you can have either 2.6 or you can have 2.7. So this is what you should account for, and now he says there are some measurement artifacts in this picture. So let us correct those measurement artifacts. The measurement artifact is this: you should set the trigger based on RX pulse instead of triggering upon wake up from sleep. Do not do this, do it based on the RX pulse. So therefore this picture again changes and this is figure 10. Now whenever okay, this 11 is not all that critical, but anyway I think I will skip it, you can read it yourself. Now what you should do is, you have variously for approximately what is the time which we said in each time in the connection interval event, 2.6 milliseconds and 2.7 milliseconds, both are there. So to improve power consumption estimate you must determine the percentage of time that each of these cases occur. How many times did you have 2.6 milliseconds and how many times did you have 2.7 milliseconds, you have to get to that point. Okay. Now performing measurements for connection events. Now typical connection event with CC2541 awake for 2.6 milliseconds, this is the waveform that you get and you see the line here, right, this is what it is. Now if you take the current waveform split into different sections, you have 1, 2, 3, 4, 5, 6, 7, you start naming them because here you really haven't labeled anything. So now you start labeling what is 1, what is 2, what is 3, what is 4, 5 and all that. It turns out that 1 is wake up, 2 is pre-processing, this is pre-RX, then is RX, RX to TX, TX post processing and pre-sleep. This is the same set of states that I showed you right in the beginning of this article. Okay. This is the note of the exact timings of pre-processing and post-processing may differ. However, the sum of the two values will always be the same, right. Since the current draw is the same during pre-processing and post-processing, these differences will not affect the average current. So essentially he is interpreting from these the above pictures a few things. Next, similar measurements need to be made using a capture in CC2541 is awake for the longest slot. This is for 2.6 millisecond, that is for shorter. This is for longer, which measures 2.775 milliseconds. So you get these numbers. Now what you do, these are the measurements for the longest awake. Then what you do, performing measurements on sleep current, you connect an ammeter and then you make a few measurements, then you find out that you get key fob will still be around 13.5 microamp, higher than it should be, and you add that also and then put everything together. I will show you what exactly he does in terms of putting everything together. Very simple folks, this is state 1 into current of that state, state 2 into the current. Take all of this, add up all this and divide it by the total awake time. So what is state 1? You already know what state 1 is. For the long it is one number, for the short it is another number. This is for long, right, this is for long. I suppose that is what you would have written here, yeah, this is the longest. So state 1, 2, 3, 4, 5, 6, you know all that. So you take those states and you multiply that into the current consumption of that see this how long that state is alive, how long the state 1 is in terms of time, multiply it into the corresponding current, add the next state, add the next state and all that, and arrive at this number. After you divide by the total awake time, you will get 8.2463 milliamperes. Now this is for the shortest. If you take 2.775, which is the longer one, how much do you get? You get 8.5312 milliamperes. So you got two numbers. Now obviously you have to take an average of both of them, right. So he does an average of both of them and then he arrives at something which is essentially, see, he takes 0.5 and he gives a weight of this current into 0.5 and he gives this current into 0.5, weightage of these two currents, right. If you do all that, you will end up with 0.0239 milliamperes. This is with proper weighting for the short and the long as well. Okay. Now because this is the average current, okay, then basically you are taking connection interval minus total wake up time into average sleep current plus total awake time into average current during connection interval divided by the connection interval. Apply this formula, you will get this number, okay. Now it is so straightforward now. Once you get this number, you know that your CR2032 is 230 milliampere hour battery. Once this battery you know its capacity, it is from the data sheet. If you buy this battery, this is its current consumption. If you divide this 0.0239 milliampere which is 0.24 divided by this 230, you will get some number. This is 9583 hours. What does it mean? It simply means 400 days. That means it is a little over 1 year. But this calculation is for what connection interval? Go back and look at the original picture, it was for 1 second. Now folks, you now make a call, how many years do you want your key fob to survive, and then accordingly play with this connection interval, you will get to know the lifetime of the system. That is all. Thank you very much. I hope you understand the importance of CI, advertising interval, the importance of CI and so on. That will give you a rounded view of why these parameters are important in BLE. So this module is about arriving at how to use BLE effectively so that you can give a good lifetime for your key fobs or systems which use BLE in their for their communication units. So that is all I have for the moment. I hope you enjoyed going through this article. Thank you very much.